Hello everyone. So today we are going to look into one of the important topic in learning data structures and algorithm, which is time complexity. This is very important because for every problem you do, you're going to calculate the efficiency of it, which is nothing but time complexity. If you really understand this concept, you can make the thing or it will break the thing. So I'm going to make it very simple to you and stick to the topic and explain it very shortly. Cool. So let's start with why we require this time complexity, and I'm gonna define the time complexity, and let's understand the time complexity by illustrating some of the examples. So why do you think we require time complexity? To analyze the problem, we have a problem statement and we are able to solve it, but there are different approaches. But how do you evaluate which approach is the best one? There comes a factor of time complexity, which we are going to calculate what approach is efficient. And how we are going to calculate this time complexity? There are some notations, and the big O notations is the main one because big O notations deals with worst case time complexity, meaning it cannot go beyond that. In worst case, it takes this much amount of time. So that is what we are going to calculate. Okay. So the definition of time complexity goes like this, and I'm gonna justify this definition by giving an example right after this. So time complexity meaning we're gonna see the growth rate with respective to input size. Okay. So time complexity, like in shortly, it is the number of steps. Okay, you can understand this as number of steps or or time taken time taken, which is nothing but we are examining the growth rate with respect to input size. Okay, so let's define what exactly this growth rate is. Okay, and I'm going to show you with an example. There is a simple for loop. Okay, there is a simple for loop and it is running from 0 to 9. Okay, it is running from 0 to 9. How many times we are running this? How many times we are running the loop? I'm gonna run it for you. For I in range 10, I'm running. So I am gonna print numbers from 0 to 9 and I am running 10 times, right? So what is the input size here? Here let's say n is the value. If n is equals to, let's say in this case for n is 10. Okay, when we keep n equals to 10, it is running from 0 to 9 10 times. When n is 10, it is running 10 times, right? Okay, if n is equals to 100, it runs 100 times. 100 times, what are the values we are printing? 0 to 99, right? If n equals to 1000 times, straightforward. So if you plot a graph for this, I'm going to show you how exactly it looks. Plot a graph, and this is the input size n, and this is the number of times we are running, number of times, time complexity, number of times we are running. Okay, so if input size is 10, number, or like simply you can say steps. Okay, we are running 10 times. If input size is 20, we are running 20 times. Okay, if input size is 100, we are running 100 times, right? We are running 100 times, right? So what is the equation of this line? It is n, right? Do you agree with me? Equation of this line n. Cool. I'm going to show you one more example where I'm going to start with 0. By default we're going to start with 0, go until 10, and what is this? Increment. Okay, so how many times this loop will be running? What I just written is, for I equals to 0, I lesser than n, I is equals to I plus 2. How many times this will run? Let's say you are running something, it doesn't matter. Let's say you are printing I. We're gonna print 0, and after that we're gonna print 1. No, we're gonna print 2, 4, we're gonna print 6, 8, right? We are not gonna print 10 because it's not lesser than or equal to. If it is equal to, we're gonna print 10 also. Okay, it's fine. So 0, 10, 2, we're gonna print 0, 2, 4, 8. So how many times? Let's say the n value here is 10. How many times we are running? We are running 5 times. Am I right? Because we are incrementing by 2. In the same example, if n is equals to 100, how many times we are running? 50 times. That's right. If n equals 1000, 500 times. So what's really happening here? If you can form an equation with respect to n and number of steps or times we are running, what would it be? In this case, input is n and number of steps is also n. In this case, input is n, number of steps is n by 2, right? N by 2. So let's plot the graph for this. Input is n, number of steps is 5. Input is 20, number of steps is 10. Input is 100, number of steps is 50. If you see closely, this is how the graph looks like. N by 2. Okay, right? When this is, let's say this is case 1. This is let's say this is case 1. Okay, straightforward. And this is case 2. In case 1, when n value is 10, we are running 10 times, right? In case 2, when n value is 10, we are running only 5 times. So what does time complexity really says? We are not worried about how many number of steps it exactly runs, but we are focused on the growth rate. In both the cases, we will write, it's a linear equation or not? It's a linear equation. It's a straight line. What about this? It's a linear equation or not? Straight line. So in both the cases, we are going to represent with big O of n. Big O of n. Making sense? We are not exactly calculating the number of steps we are going to run, but we are going to calculate the growth rate. So the time complexity would be big O of n in both the cases. I'll give you one more example. Let's say for I in range, I equals to 0, I lesser than n, and I equals to I plus 3. How many times we are running? Let's say like input size is n. We're gonna run n by 3 times. How exactly? Let's say n equals to 10. We're gonna run 3, 6, 9, 3 times. N equals to 100. If you see, it's gonna run closely how many times? 33 times, right? right? N divided by 3, because every time we are incrementing by 3, I value by 3, so it will be running 33 times. So if you plot a graph for this, it will look something like this. Okay, see, I am not telling it is greater than the second case where we are running n by 2, or it is greater than the first case, but I am telling we are not worried about the exact number of steps. It's still a straight line, and we are going to represent with big O of n. So it doesn't matter whether it runs, whether it can be anything, n divided by 2, n divided by 3, n divided by 100, n divided by n plus 1 divided by 2, anything. It could be anything, but it's still a linear equation, right? The degree of n is still 1. N divided by 50, degree of still is 1. So this is what I meant by growth rate with respect to input size. Cool. So in everything, it's a straight line which is big O of n. Okay, so we have seen what is big O of n, and I have shown you different examples of big O of n. Cool. Now we are going to look at big O of n square, second case. Okay, I am going to give you one more problem. Time complexity big O of n square. Guys, it's going to be very simple. What I'm going to do is I'm going to write here the complexity of this is big O of n. You all know this. And what am I doing is I'm writing one more for loop for I in range 10. Let's make it simple. Anyway, it's starting with 0, so let's remove it and print. You can print anything. You can print here also. It doesn't matter. Or let's print z. Okay, but let's print z and print. This is for a new line. After inner loop is running n times, we are going to print a new line. Okay, what it will print? Can you tell me what this will print? See, this is my question. What this will print? Or let's make it very simple. Let's make it easy. Let's make it 3. Okay. For I value 0, inner loop will run how many times? 0, 1, 2, right? And we are printing 0, it's fine. And we are worried about how many times it runs. And it goes to new line. When I value is 1, inner loop will run again 3 times. 0, 1, 2. I will go to 2, range 3, it will still run. J will run 0, 1, 2. That's it. Is it making sense? I'm going to run it. Zero, 1, 2, 0, 1, 2, 0, 1, 2. Let's print it in the same line. Inner loop. 0, 1, 2. Inner loop for I equals to 0. Inner loop is running 0, 1, 2, 3 times. For I equals to 0, it is running 3 times. For I equals to 1, it is running 3 times. Right? For I equals to 2, it is running 3 times. Totally how many times it is running? 9 times, right? 9 times. So when n value is 3, how many times we are running? We are running steps 9 times. Am I right? If n value is, let's put it simply like this, n equals to 5. If n equals to 3 and I want to place it n and I'm going to place it n, yeah, let's simply change n equals to 5. How many times it will run? Guess. 25 times. That's right. For I value 0, inner loop will run 5 times. I value 1, inner loop will run 5, 2, 3, 4, right? So it is, if n value is 5, it's going to run 25 times. So if you can form an equation, what it would be? It is n square times. Am I right? Am I right? N square times. Cool. I hope you did understand this, right? And if you have understood this, you can also understand my next question. What is the time complexity of it? Okay. So we have just seen this big of n square, but I'm gonna ask you some couple of problems as well. Cool. So if you have really understood this, please tell the complexity of this problem. For I in range 3, for I in range 2, what is the complexity of this? Or let's make it more simpler. In this case, there is only one variable, n. But now I am taking two variables, m and n. Outer loop is running m times, inner loop is running n times. Okay. First, let's predict the output. What will be the output? I'll make it easy for you. Just a minute. Yep. If you have really understood the problems, you should be able to tell the time complexity of this. What is the time complexity? First, let's predict the output, and then we can analyze the time complexity. Okay, outer loop will range 3, right? So here m is 3. Here range 3. Here range is 3. And here range is 2. Okay. Now I will be starting with 0. I will be going to 1. I will be going to 2. That's it. I won't go to 3 because it's not inclusive. When I equals to 0, j will be 0, 1. Yeah, it won't go to 2 because it's not inclusive, it's exclusive, right? So 2 times. When I equals to 1, we're going to print j. J is going to run j equals to 0, j equals to 1. When I equals to 2, j is going to run 0 and 1. Is it so? Let's check. 0 1 0 1 0 1. Okay, that's good. So here, what is the coming to definition? We are gonna, time complexity is nothing but, time complexity is the growth rate with respect to input size. Input size. So in before examples, there is only one input, but which is called n. See, we are representing in with respect to input size, right? In terms of input size, there is only one variable, n, in all the cases before. But here, there are two variables, m and n. right? So there are input size. With respect to input size, meaning we should make use of two variable because it is dependent. The number of times we are running is dependent on m and n, not solely on m or not only on n. Okay, so if m equals to 3, n equals to 2, for every value of I we are running j times, 2 times. So we are running 2 times for 3 times each completely. So 3 into 2, simple mathematics, 3 into 2 would be 6 times. 6 times. Why 6 times? Here 3 is nothing but this is m times, right? Outer loop is running m times, inner loop is running n times each. So totally we are going to run m into n times. M into n times, right? Am I right? Is it so? M equals to 3, n equals to 2. You can try with any other example. Let's say m equals to 5. Outer loop is running 5 times and inner loop is running 2 times each. Totally we are going to run 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Cool. So it is not big O of m or not big O of n, but it is big O of m into n, right? I hope you understood this. Cool. Saying that, we're gonna move to one more example and try to understand the time complexity of it, right? So yeah, so I'm gonna give you a problem straight away and let's analyze the complexity. For I, or it can be for loop or while loop. See, what is the time complexity of this? For I in range 10, print I, the time complexity of this is big O of n, right? You have seen this. The same thing also we can write it in while loop. While I is lesser than 10, print I plus equals to 2, and we need to initialize I equals to 0. Both are same, right? Yeah, both are same. The same thing which I wrote in for loop, I wrote it in while loop. Both are same. So I'm going to show you an example, and it's you can completely do the same thing whether for loop or while loop. The time complexity remains the same thing. We're going to test the number of how the growth rate is happening with respect to input size. So you can tell me whether I have to do it in for loop or while loop. Or okay, let's take make this example with while loop. So we're gonna get used to it as well. So I equals to 1, I equals to 16 or lesser than equal to 16, it doesn't matter. I'm gonna print I, and I is equals to I into 2. What is the time complexity of this? Before examining time complexity, let's see how many steps it runs. Okay, so this is the problem. Cool. I is 1. Let's say this is nothing but the n value, the limit. It can be 16, it can be anything. In this example it is 16, n equals to 16. Okay, so when n is equals to 16, when n equals to 16, how many times we are running the loop? We're gonna print I, which is 1. 1 is lesser than 16, so I equals to 1. And next time, what is I value? I equals to I into 2. So next time we are checking, is 2 lesser than 16? Yes, we are gonna print 2, and we are updating I equals to I into 2. Now I equals to 4. 4 is lesser than or equal to 16, right? Yeah. And next time 4 into 2, 8. Next time lesser than 4, 8 into 2, 16. So if we keep lesser than, it's gonna run. If not, it's not gonna run. Okay? Cool. Let's say if it is not there, okay? Just to make things easy. Because adding one extra step is not gonna change anything, right? So when n equals to 14, can you tell me what is its time complexity? Is it big O of n? Is it big O of n square? No. Is it big O of what? See, definitely it's not n, because you can see it's definitely not running 16 times, or it's definitely not running more than 16 times, right? Then how many times it is running? How? See, like I'll tell you exactly. It will run big O of log n times. You know the definition of log, right? See, 2 power 3 is equals to 8. We all know this. And log 8 to the base 2 is equals to 3. This is the definition of log mathematically. If 2 power 3 equals to 8, log 8 to the base 2 is 3. So here, what is the log 16? Log 16. What is the value of log 16? Log 16, 2 power 4 is equals to 16. Log 16 to the base 2 equals to 4, right? We are exactly running 4 steps. 1, 2, 3, 4. If you want mathematically, I can show you mathematically. Like, it is 2 power 1, it is 2 square, it's 2 cube, right? It is 2 power 4. And it is gonna run until unless this value is lesser than or equal to n. Okay? Cool. Let's say it's equals to n. Then 2 power 4 nearly equal to n. Then how do you justify this? How do you represent in terms of n? How do you represent this? How many times it is running? 1, 2, 3, 4 times. 4 times. How do you, it is running k times? Exactly. Let's say first time, second time, third time, fourth time. So it is gonna run 2 power k times. We're gonna determine this k. So how do you represent k in terms of n? It can see, it is simple. Like, it is running 2 power 4 times. It can run any times, like if it's say 2 power 32, 2 power 5, fifth time. So it's gonna run k times, and it is 2 power k. The value is 2 power k. The value will be 2 power k, and it will stop until unless if it is lesser than or equal to this 2 power k is less than or equal to n. And how do we represent we should determine the k, because we are determining k steps. So apply log on both sides. So it will be like log of 2 power k, right? So 2 power 2 to the base 2 will be cancelled. So k is big O of log n, right? See, this is the mathematically if you want to like determine, but in short you can exactly see how many times it is running. We are definitely not running 16 times, so we are running 4 times. 1, 2, 3, 4. right? So the time complexity of this is big of log n, right? Big of log n. So one last thing is there, which is so there is one more big O notations. We'll come to that. So this is very easy and simple, and I'm gonna explain it. Okay, let's say I am printing 3. I'm just printing 3. What is the complexity of it? It is single step, right? Or I am printing n. Here the input is n. N can be anything. N can be 4 or n can be 400. I'm printing n. How many times I'm printing? One time. Okay. What is the complexity of it? What is the time complexity? Time complexity is big of 1, meaning constant time. See, I will show you graph. This is n and this is steps. When n value can be anything. Here n value need not be 400. N value can be 1, n value can be 2, n value can be 3, n value can be 400. It can be any value of n, but number of steps we are running is only 1. So how does it looks to you? Constant, right? Okay, if I print n again, I am printing n value can be anything. I am printing it 2 times. What is the time complexity? Big of 2. No, there is no big O of 2. There is only big O of 1, meaning constant time. I'll tell you why. We are printing 2 times, which is doesn't matter. If n value is 1, n value is 2, 3, n value is 1000, we are running only 2 times. How does this line looks to you? Constant, right? So big O of 1 doesn't mean we are running 1 time. It means we are running constant number of times. So the time complexity of this program is, it doesn't matter if you are printing 2 times or 3 times, because it's always constant. It is not changing with respect to input size. It is always constant. And how does a constant line looks like? This. So it's big O of 1, right? But if you see a loop, it is changing with respect to input size. It changes with respect to the number of steps, changes with respect to the size of n. But in this case, it doesn't change. We're just printing number. It can be anything. Let's say I'm printing modulo 2. I'm just printing modulo 2. How many steps? Only 1 step with respect to input size. And can be anything. We're running only 1 step. So the time complexity is big O of 1. So with that example, we have completed the basic big O notations: big O of n, big O of n square, big O of log n, and big O of 1. So I hope you are clear with complexities now, and you can also try out with different set of examples. And for every problem you do, you try to question yourself, okay, what is the time complexity of it, how many times it runs with respect to input size. So it will give a better picture of understanding time complexity, and you're going to learn it slow and steadily, because for every problem you do, you're going to calculate time complexity. And the thing which we have discussed, this notations is not only limited to time complexity, but it is also used for space complexity. Cool. I hope you understand the lecture, and I hope you enjoy the session. Thank you.
Yeah.